Hello guys, my name is Emmanuel and I'll be demonstrating building a CCTV enhancement system with you. The enhancement will incorporate features like simulating biometric authentication, real-time alert mechanism, dynamic CCTV motion tracking. I'm going to be using tools like the Arduino Uno, a full breadboard, jumper wires and stuff. Without wasting much time, let's get into the project. Okay, so these are basically the tools that we are going to use for the simulation. We have our Arduino Uno Alter, our full breadboard, our Arduino cable, and then set of jumper wires. You can also see we have our buzzer, ultrasonic sensor, photosensor, servo motor, and then our RGB module to simulate the alert mechanism. Okay, so here we are. So for the video not to be so long, I'm not going to write the codes. I'll just share my pre-written codes in my comments. So getting into designing the circuits, setting up the circuit, sorry. I'll first start with my ultrasonic sensor, which will detect the distance. It's going to simulate motion detection. So the ultrasonic sensor will first detect the distance, and then the servo motor, which will serve as a simulation of the CCTV tracking system. Yeah, will rotate to the angle that the sensor detected the motion from. So yes, on the breadboard it has numbers and then letters to show the columns that we are making our connections. But then it doesn't really matter where you are fixing your components on the breadboard, because the pins that you are fixing your components will be defined in your code. So as you can see, I place it anywhere, which will not affect how I'm going to run my system. The actual effect will be from the code. So let me check my code and see the pin that I can put my buzzer pin, sensor pin. So you can see that our Arduino Uno board doesn't have enough 5V pins, 5 voltage pins. It's just one 5 voltage and 3 voltage pins. But then looking at our components, the buzzer, the sensor, which is the ultrasonic sensor, the photosensor, and the servo motor all need to be connected to 5 voltage power. So this is how we are going to share the power. We are going to make connections from the GND, the ground, and then the 5 voltage onto the breadboard, and we share the current across from the breadboard. So I'm fixing my jumper wires into the 5 voltage and then the GND pin on the Arduino Uno, and then putting the 5 voltage pin at the positive side of the breadboard, and then the GND pin at the negative side of the breadboard. So this is what is happening. The current is being flown through all these holes. So once I connect my jumper wire from this positive side on the breadboard to the positive side on the positive pin of the ultrasonic sensor, it shares the current across. So in that way, I have 4 extra 5 voltage to share, 4 extra GNDs to share. So like I was saying, the definition of the pins, which is, so our ultrasonic sensor has a trick pin and an echo pin. It doesn't really matter where we place it in our breadboard. It is the definition on our code that will matter. So per my code, the trick pin is in pin 6. So I'm going to connect my trick pin here, my echo pin here, and then per my code, trick pin is tapping from digital pin 6. You can see on this side of the board. So digital pin 6, that's my trick pin. The green jumper wire for my trick pin, and then the brown for my echo pin, which is connected to pin 7. Okay, so guys, So that's it for the ultrasonic sensor. Now I'm going to fix our servo motor. So if you look at our servo motor, there's no indication of which pin is the GND, which pin is the power, and which pin is the input. So this is how you know. The red pin, the power is always indicated by a red wire, so which connects to our middle pin, and then the GND or the cathode is represented by a brown or black wire. So this is how you know from my micro servo 9G SG90. So the cathode or the GND is a brown wire, and then my input or output is my orange wire. So without wasting my time, let me do the connections. So this one doesn't go if not for the fact that you want to be tapping the 5 voltage and then the GND from the breadboard. It would have gone directly to the Arduino Uno R3. So red, brown or black for the cathode. Yeah. So this is my black, this is my cathode. So going into the negative side of the breadboard. My power going into the positive side. Well, that's where I'm tapping the 5 voltage from. And then my output. So my input or output per my code, my servo pin is supposed to be inserted into digital pin 9. So I locate the digital pin 9 on the Uno R3 and fix it. Yes, so that is about it for the rest of the components. All you need to do is to locate your GND pin from the component, connect it to the negative side, locate your VCC pin on the component, locate it to the positive side, and then your input or output pin, depending on your preferred pin, whether digital or analog, you just insert it and define it in your code. So for the video not to be so long, I'm going to elapse this part so we are done fixing our components. Okay guys, so that's it for the setup. So as you can see, all my components have been connected to my Arduino Uno through my breadboard. Yes, and then other ones that were directly connected. So we are coming to test the circuit. So this is how the system should work. The ultrasonic sensor detects motion. So once it detects the motion, the servo motor tracks the motion. That's it rotates to the angle or the direction that the ultrasonic sensor detected the motion from. So when it rotates that's simulating the CCTV. So the CCTV will rotate to that direction. Then the photosensor, which is simulating our biometric authentication, will scan the object. If the photo value that will be received is not equal to any of the default photo value that I have set, the RGB model is going to on red and the buzzer is going to be indicating unauthorized. I'm going to go through and vice versa what each line of code is representing. So to use a servo motor, you first have to include the servo.h from the Arduino library. So as you can see here, the highlighted one, I was including the library to make my servo motor run. Okay, then these are my pin definitions. Like I was saying, it doesn't really matter the pin you put your components in on the breadboard. What matters is how you define it in your code. So this is my pin definitions, as you can see over here. Trick pin, my trick pin, echo pin, photo pin, buzzer pin, red pin, green pin for the RGB models, blue pin as well, and then my servo pin. Also, this is what I use to call my servo. So servo, my servo, the servo motor. So boolean, I was setting motion detected to false. So initially it is set to false. So once it detects motion, once the sensor detects motion over here in my loop code, once the sensor detects motion, the motion detected is now set to true. So once it's set to true, the track motion function is initiated. Once the track motion is initiated, it means the sensor has detected motion. And then once the sensor detects motion, so the photo sensor will also start scanning. So if the photo value is equal to this value, then it should trigger alert. That's for unauthorized access. Else, allow access. So these functions have been defined in my code down here. So this is my trigger alert function. So this is what is happening. So this is the alert. It will turn on the buzzer, which is this code right here. Digital write buzzer pin high. It activates the buzzer, sets the RGB to red, and then delays for 2 seconds. That's the beep duration. And then stop. So it will beep for 2 seconds and then stop, and loops again until the person leaves the threshold. And then there's the allow access in case the person is authorized. It sets this one to the RGB model to green over here, and then stays green for 1 second, off, and then comes back on until the person leaves the distance threshold. Yeah. So this was a function to set in my RGB colors. You need to define them as well. So this is how I was logging my errors. So I'm saying it should print whatever distance it is recording, the sensor is recording, and then whatever value the photo sensor is giving. So this was my code to log that error in my serial monitor. So this is about it. I'm going to leave this code in my comment section, or preferably my GitHub, so that you guys can check it out later. Thank you. Okay, so there's a demonstration. So there's it. The sensor is sensing the object here, which is this object. But then because the object is not in the threshold distance that I have set for the trigger alert to run, that's why it is not detecting whether it is authorized or unauthorized. So this is what is going to happen. To simulate this instance, I'm simulating authorized access. So you see that once I bring the object close and it gets into the threshold distance I have set, the photo sensor will scan it, simulation biometric authentication. Then if it is authorized, the RGB model is going to on green, indicating authorized access, and then the buzzer won't beep. So there's it. So this indicates authorized access. You can see that the buzzer is not beeping. The RGB model has turned green, indicating authorized access. So these are the instances, some of the instances that it can be used. So let's look at the unauthorized instance. So unlike the other objects, this one, when it gets close to the threshold distance, the buzzer starts beeping and then the RGB model turns red, indicating an unauthorized access. So let's look at how this works. So as you can see, when it got close to the threshold distance, the buzzer started beeping and the RGB model turned red. So thank you guys for staying with me. This is the end of the setup. Bye bye.